Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 3.2.4. The M&Ms for this particular lesson are not telling us how to solve an equation with one variable, but the fact that solutions can vary. Sometimes you have one solution, sometimes there's no solution that'll ever work, and in some situations there are an infinite number of solutions. So here's an example of a solution an equation where there's one solution. So by the time you took away 3 x's from each side and added 2 to each side, you came up with a solution of x is equal to 5. So that's the one solution, right? And of course we can plug it in and we can check it to prove that when x was equal to 5, both expressions were equal to each other. So this typically is the way it works. We usually get one solution for any of these equations. But in some situations, we don't get any solutions. For instance, if we have x plus 2, well, x has to be equal to the same thing on both sides of the equation. Otherwise, you'd use a different variable. So there's no way that x plus 2 can ever be equal to x plus 6. So in this situation, there would be no solution that would ever make that work. And of course, there are some times where the expressions on both sides of the equation are actually the exact same expression. So no matter what number you plug in for x here, the same number gets plugged in there and both sides will always be equal. So you can plug in the number 0, 1, 2, 3, 4, 5. All real numbers work as solutions. So you would either say all numbers work, or you could say there are infinite solutions. All right, some diamond problems. Remember, when you multiply the 2 numbers on the sides, the product gets written at the top. And when you add the 2 numbers on the side, their sum gets written on the bottom. So we use some algebraic reasoning here. What do you multiply times 1/2 to get 1 for an answer? Well, that would be 2, since 2 times 1/2 is 1. So now we'll add the 2 to the 1/2 to give you 2.5. Here, this is where we start getting into some algebraic reasoning. And I'm going to go ahead and give you a kind of problem that you'll see in high school. So if you take x plus, no, we don't want to go in that direction. We don't want to do that. That's the wrong way. Okay, if we said x squared plus 7x plus 10 was equal to 0, then we would be trying to factor this out to find out what our 2 solutions are for this given equation. We know the only way you're going to get an x squared here is if you had multiplied x times x. So that's going to be the given. Now, we have to ask the question, what 2 numbers can you multiply together to give you 10 for an answer that when added gives you 7 for a sum? And those numbers are 2 and 5. So in factored form, this expression factors out to x plus 2 times x plus 5. Now, to solve for x, that takes us to the next step. We're going to use the zero product property that says whenever you multiply a number times 0, you get 0 for an answer. So, oh, that's supposed to be a p there, property. So therefore, if this times that equals 0, then either this is equal to 0 or that is equal to 0. What would make this expression equal to 0? Well, if x was equal to -2, then -2 plus 2 would give you 0 for an answer. And it wouldn't matter what this is equal to because 0 times anything equals 0. What value for x would make this expression equal to 0? That would be x is equal to -5. So to solve this equation here, we now have 2 solutions. We have x is equal to either -2 or x is equal to -5. Both of those numbers, when you plug them in for x, would make this expression equal to 0. So the whole reason why we've been doing these diamond problems since the beginning of 7th grade is to prepare you for this high school math. And hopefully go ahead and work those out. If you want me to work them out for you, I'd be happy to. Otherwise, I'm just going to move on right now. All right, Joe is downloading songs from the internet. You can download them at a rate of 8 songs every 10 minutes. And Jasmine, she downloads 12 songs every 15 minutes. So who's downloading the songs faster? This is where we want to find the unit rate. And your unit rate can be the number of minutes per song or the number of songs per minute. It doesn't really matter which direction you go in. In this case, I I did the number of minutes per song, and it turns out they're both downloading at the same rate. 15 divided by 12 is 1.25, and 10 divided by 8 is 1.25. So both of them are downloading songs at the same exact rate. All right, solving equations. Go ahead and take a look at these. I don't know, maybe I'll solve this one for you. I'll show this, and if you want me to show you any of the others, let me know. So I don't like this negative sign on the outside of parentheses. So I'm going to send in the dive bombers and take the opposite of each one of those. That becomes x minus 6 is equal to negative 3x. I would normally want to collect my x's on the left side, but I've already got my number over there. So I'm going to take away an x from each side, which means I'm going to add 1 negative x to 3 negative x's that are already there to give us 4 negative x's. So that means that whatever you multiply times negative 4 to give you negative 6, that's going to be your solution. So let's figure out what that number is by dividing both sides by the negative 4 to cancel that out. So negative 6 divided by negative 4 is the same as 6 divided by 4. And you get 1.5. So that is your answer. X has to be equal to 1.5. All right, I think this might be the last problem. No, it's not the last problem. We got a couple problems. So use your pattern finding skills to copy and complete the table. All right, what do we know? We know that this number, that's interesting. What is going on here? 1 plus 23, absolutely not. 2, oh, I see what this is. This is a very unique type of a situation where the product of these two numbers is always going to be 24, no matter what. So y is going to be equal to 24 divided by whatever x is. So 24 divided by 2 is 12, 24 divided by 3 is 8, 24 divided by 4 is 6, and so on and so forth. So that becomes the rule right there. If you were to multiply x on each side, you'd get it looking like that. So once you graph this, this is an interesting type of a graph. This is one of those types of problems where you might say, all right, it takes 24 man-hours to clean out the garage. Assuming everybody works at the same rate of speed, how long would it take one person to do the job? 24 hours. How long would it take 2 people to do the job? It would take 2 people 12 hours. Since each one of them would be working 12 hours, that would amount to a total of 12 or 24 total man hours. How long should it take 4 people to complete the job? 6 hours. How long would it take for 24 people to clean out the job or clean out the garage? That job would take a total of 1 hour because each person is working for 1 hour for a total of 24 man hours. Now, what makes this an interesting situation is how long would it take for 0 people to complete the job? Well, that's impossible, right? If nobody's working on the job, it doesn't get done. So this graph will never, ever touch the y-axis where x is equal to 0, and it will never, ever touch the x-axis where y is equal to 0. Because that's an impossible kind of a situation for the nature of this problem. Think of it up here. If x is equal to 0, there's no value for y that could ever make that equal to 24 because the answer would always be 0. And if y was equal to 0, there's no value for x that would ever make that equal to 24. So in a graph like this is called an indirect variation type of a graph. You get a curve, a nonlinear kind of a curve, and it will never, ever touch or cross over either the x or the y-axis. All right, translate each algebraic expression into words. I think that's pretty straightforward. The words that you chose to use may be different than the ones that I chose to use. Just go and pause it and look and see what I wrote and see if it makes sense, and read what you wrote and see if they are similar. And I think that's it. That's the end of our homework for today. So good job. Hopefully you got most of those answers correct. And now let's move on to our next lesson.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. best.